My name is Derek Bailey. I've been a wood turner now for over 40 years off and on, and taught for 8 of them. After doing my previous video on tool sharpening, it's time to introduce beginners to their first bowl. I'm using the little Axminster lathe, which has only a 4-inch centre height and a little 250 watt motor. The block of Iroko that I'm putting on is about 7 inches square, giving a bowl around 6 inches diameter. The little lathe, treated with respect, did not prove reluctant towards the task and did not let me down. Anyway, that's enough waffling. Let's get on. Well, this is the maximum blank size I can get on this little lathe. It's 8 inches across corners. Obviously, if you have a bandsaw, you can cut the corners off. You could probably get another inch diameter if you didn't have to remove the corners. I'm making the dividers just slightly larger than the radius of the faceplate that I'll be using to hold the blank. This is so I can centralise it by making sure that the gap between the diameter of the faceplate is even between the diameter of the scribe circle. I'm never keen on screwing directly into the wood without making a pilot hole first. Some bad experiences of the past have occurred when the screw itself has sheared off and left itself in the wood, and it takes a heck of a job to try and get the thing out. So using a pilot hole for the screws, better safe than sorry. I don't finalise the tightening of the screws until I've got all of the 4 nicely fixed into the wood, and then tighten up just to make sure. It's easier to line up sometimes, although ideally the screws should be near exactly the same size of the holes in the faceplate to prevent any movement. Due to the fact that it's a maximum square blank that I can get on this little lathe, I'm erring on the side of caution by using the grub screw to tighten it against the drive shaft of the lathe. Vibrations and slightly out of balance work can often vibrate small lathe threads loose from the thread in the faceplate. For added safety, I brought the tailstock up and held it in place, just in case it does decide to unscrew. It can't go very far with the tailstock and the revolving centre holding it in place. I've set the lathe on minimum revs, and now it's just a case of standing to one side and switching the machine on. Not forgetting to tighten the grub screw, of course. There's a little bit of vibration as the wood turns round, but nothing I can't handle, and it's not too terrifying to prevent me from starting to turn. I'm using a 1/2 inch bowl gouge for this operation. It's quite substantial, it's only a small blank, even though it's on a small lathe. This is what happens when you have 4 corners whizzing round. You can see the ghost effect, like a cloudy image just above the actual wood itself. Now I've got it on the lower speed here, just to take, but the problem with the lower speed is that you've got a slow intermittent cutting, and the temptation is to move the tool along the tool rest quickly, which is more than the lathe can take, especially this small one. So you've got to go extra slow until you've removed a lot of the corners. You have to persevere with this. With only being a small lathe, it can't stand big cuts. So be patient, take it slowly until you get down to a smaller diameter, less vibration, then you can speed the lathe up. It's easy to get carried away with removing wood without noticing the reduction in diameter of the wood, which can happen quite quickly. So always stop and move the rest closer. You don't want too much overhang of the tool beyond the tool rest. General rule of thumb is that you have an overhang roughly about 3 or 4 millimeters longer than the bevel of your bowl gouge. A big temptation, especially for beginners, is to press the bowl gouge against the wood more firmly. It's counterproductive, because the more you do that, the more the wood slows down and there's more forces against the rotation of the lathe. So what you need to do is to just imagine that you're cutting a straight line along the wood and press more firmly down on the tool rest, and just imagine that you're not actually cutting wood. I know it sounds strange, but just imagine that you're drawing a line across the wood. Don't press onto the wood to get a cut, just let it take a cut. Slowly move along the tool rest without pressing against the wood, and you'll find that you get a more consistent cut without too much strain on the horsepower of the lathe. This is a lump of wood I just found knocking around, and it's pretty hard to identify wood on colour alone. Without a microscope and a scientific education, it's very difficult to identify wood, but I suspect this is a Roko, and there's some quite hard spots on it, particularly to the left. It goes quite harder, so there was a little bit of difficulty in turning this wood, especially due to its abrasive nature, which sent me to the tool grinder on quite a few occasions, but eventually it was overcome. This is a little bit of a learning curve for me. Having worked on a far more powerful lathe, I could be ripping wood off far faster than this, but I'm having to I'm having to draw back a little bit and just take small cuts so that I don't slow the lathe down, which is quite challenging, but I'm quite enjoying it really. I've introduced a second camera now on the bottom right hand corner. As you can see, I'm taking quite small cuts. I'll be lucky if it's a millimetre, probably half a millimetre that I'm doing, but patience has to be used here, and let's carry on. I won't bore you with watching me taking millimetres off the wood. I'll do an edit here and speed things up a bit. Right, now I've done the diameter I want, I'll just clean up the face a bit with the bottom wing of the ball gouge. As you can see, I'm just lining up the bottom wing of the ball gouge with the centre of the wood. Notice that I've got the handle of the ball gouge slightly downwards from below the centre. This is to create a little more shearing action rather than a scraping action, which tends to leave a better finish. The cutting action of the ball gouge is okay. I could do with it being a little better. I'd love to see ribbons coming off. There's quite a bit of dust, which worries me that some of the grain might be torn. Yes, it's very abrasive timber is this. It's dulling the edges of my tool quite quickly, but I think it's going okay. If by any chance you've seen my previous videos and using the bottom wing of the ball gouge, it's just a matter of half a millimetre gap with the top wing without actually touching the wood, which acts as a guide, and just leaning back with the tool. Don't move your arms, lock your arms to your body and just lean backwards and forwards with your body. That will create a much easier cut to keep square, and a regular cut as well. So it's an even cut all the way along the diameter of the wood. I'm just experimenting a little bit with this wood and the power of the lathe here. I'm just taking some cuts on the top and see just how big a cut I can take before I start removing wood to the shape that I need.
Dutch fans game will be one of the best group games we'll have.
I've decided to do a concave outer rim of this bowl, but I have noticed there's a slight vibration which is accentuating the effect of the abrasiveness of the wood itself. So again, more frequent visits to the tool grinder, I'm afraid. Another slight problem I encountered was a small amount of regular vibration, which doesn't help the cut and doesn't help keeping a nice sharp edge to the wings. What I suspect it is that the lathe is driven by a kind of timing belt, which does have a little, what shall I say, vibration as it rotates along the pulleys. And because of the diameter of the wood, it's emphasised a little more. The larger the diameter, the more I think it's emphasised. It's not a problem. It's a little bit strange that the wood isn't coming off in lovely ribbons, but it is dry, so I can't expect too much. As I become more ambitious with the cut, I notice that the lathe is tending to just slow down a bit, so I've speeded it up to give it a little bit more torque. Here I'm taking about 4 millimeters, 3 or 4 millimeters cut, and the lathe is beginning to labour under the torque. There isn't enough torque from the lathe. With these little lathes, if you speed them up, you do get a better torque. They're very low torque at low revs. So it's a matter of just speeding the lathe up a little bit in increments until you're getting the cut that you want. But you will get some slowing down. Just ease off the pressure and carry on. You still get there in the end. As you notice, I'm going up the hill. The bevel is following the direction of the cut. I don't deviate either way. The bevel just rests behind the cut just a little bit when you're actually what they call riding the bevel. Try not to take too much off, and don't start persevering with twisting the tool, etc. to get a better cut. Just follow the direction of the movement of the tool and let the bevel follow after the cut. I've kept the sound up here so you can hear the lathe slowing down as I put pressure on a deeper cut. It's just something you have to put up with these small lathes. Don't give up, they'll still do the job. Oops, getting a bit carried away removing wood again. Stop the lathe just for a second. So I just speeded it up a bit more to give it a bit more torque and carried on. Contrary to spindle turning, it's okay to go up and downhill. You'll find out which way the grain is. A bit like when you're planing, you don't necessarily know which way the grain goes when you take your first planing cut, but you'll soon find out which is that produces the better finish. If you notice, I'm pulling the bow gouge towards me. The normal procedure for this is to stand behind the cut and push forwards, and that's when you get a better idea of what riding the bevel is. You're actually pushing, you're leaning forwards with the cut. Here I'm leaning backwards with the cut, and the reason for that is that the lathe is so underpowered, it gives me a better feel to when I'm slowing the lathe down or not. I think if I was pushing the cut, I'd tend to force the cut beyond what the lathe could cope with. For the advanced turners like Ashley Harwood and Stuart Batty, they have a technique where they have the tool well away from the body, they push the tool towards the wood, but their skill is so that they can tell the difference in friction between the cutting edge, and it's instilled in them that they can manipulate the bevel to such an extent that they don't create any end grain tear out, and the finish is usually quite good. It's an acquired skill which depends totally on feel of the bevel rubbing against the wood. Now I've changed the angle of the tool as I pull backwards. I'm using the bottom wing of the tool to create a shear action as I did on the face of the bowl. I'm now using it on the outside of the bowl. The reason that I'm doing this is that the finish left by the bevel on the tool isn't even along the full length of the curve, so I'm using this shear action scraping to iron out all those slight bumps that have been left by the bevel use of the tool. Now that I'm happy with the finish left by the shear scraping action, I'm introducing good old abrasives. You can always rely on it to iron out even further and get the finish that you need. I'm quite happy that I haven't torn any grain, which is brilliant. Usual procedure with the Abranet mesh abrasive is start off at 120 grit and work my way up to 150, 180 and then 240. Then I'll introduce the Yorkshire grit, which colours the wood darker but leaves a lovely silky finish. Having made sure that the base of the bowl is nice and flat, and obviously with the plywood false base being glued to it should be flat, I've clamped the whole thing together using the tailstock, and I'll just true up the false plywood base before I leave the whole thing to cure overnight. Before I left the assembly glued together by PVA glue, I thought I'd just true up the false base, and I noticed a knocking noise, as you can hear. I'd forgotten to tighten the lever on top of the tailstock quill, and I carried on thinking, oh no, I've got bearing trouble. But as soon as I used the lever, it took that awful noise away and I felt more reassured. Now I've allowed the assembly to cure overnight, let's get on and clean up the face of the false base. The temptation is to take the tailstock away from the wood, but I'm still erring on the side of caution in case the glue hasn't quite done its job. Here, as you can see, I'm taking the large nub at the centre of the plywood off with a push cut. If I'd have thought, I'd have started off with the raised portion in the middle and pressed along the axis of the lathe so that it wouldn't test the joint of the glue. But I felt secure enough to use a push cut to get rid of the lump in the middle. You need to make sure that the base of the false base is flat, so that the faceplate, when I've unscrewed it from the bowl, will fit securely on the false base. Here I'm measuring the diameter of the faceplate. Now reproduce that diameter in a small locating recess in the base of the false base. Here I'm using the inside of the vernier calipers to scribe a diameter on the base of the false base. What I've done is I've put the left hand prong to scribe the line and the right hand prong without touching the wood to see that it lines up with the scribe line I've made, and I adjust accordingly until the two line up together. It's an old procedure often done with dividers, but I've used the inside prongs of the vernier caliper for this. The vernier caliper method was a bit of a silly idea really, because it left a scribe line that was a little bit too wide and didn't give a precise edge to it, so I've reverted back to the dividers, which have a sharper point. I won't be doing that again. It doesn't do the vernier calipers any good anyway. I'm just emphasising the diameter of the scribe line with the 1/16 thick parting tool, and then I'll clean up the rest of the wood inside the diameter to accept the faceplate. Now that I'm confident about the gluing of the assembly, I can use the push cut to take away the centre. before I take it off the lathe and remove the faceplate, I'm just checking to see that the diameter is good enough for the faceplate. It's a moment of truth, but I hope my measurements are correct. It's satisfactory. It's not an exact fit, probably about about half a millimetre play, but it's okay to make it run reasonably concentric when I put it back on the lathe, so everything should be fine. On an earlier video I did a wood carving and ornamental turning jig, and I had left the fence work, as you can see the wood that's been attached to the lathe, the wood fencing. I had to remove that because it would interfere with the handle of the bowl gouge at a later stage. Here I often say in my previous videos when I'm turning, the sweet spot, whether it's the spindle gouge or the bowl gouge, is just below centre of the flute. Just have a look at this diagram and I'll try and indicate that position. And what you have to do is to maintain that position throughout the cut. As you're turning, always keep a close eye on that position on the wing, or just below centre of the flute, and allow the bevel to rub behind. Don't press on too hard with the bevel, or else you'll create undue tool marks. Just follow the bevel along and watch the sweet spot as it goes towards the centre of the bowl. Because the flute of the bowl gouge is away from me, my approach angle is in a situation where I pull the handle towards me and press against the wood. This prevents the skidding action, and then once I establish a cut, then I can push the handle away from me and introduce a sweet spot and progress towards the centre of the bowl. If you noticed, I did a quick adjustment then and turned the bowl gouge 180 degrees so the flute's towards me. This is to provide a scraping action, a shear scraping action of the bottom wing of the tool, just to even out some of the undulations caused by the previous bowl cutting action. Now I'm starting to approach the rim of the bowl. I'm swung the tool round virtually in a mirror image to what I was previously cutting. I'm still cutting on the sweet spot, but now I'm cutting on the lower wing. That stops me from skidding along to the outer diameter. If I kept that position I was cutting in previously, there would be a temptation for the tool to skid across the face of the bowl. But here, by switching the angle, it eliminates the tendency for the gouge to skip across the surface. Once you've established the cut, then it's a matter of feeling the resistance of the wood against the edge of the tool, and maintaining that that resistance right through to the centre of the bowl. Swing the handle round, maintaining the slight bevel contact behind the cut, and that's what gives you that feel. The bevel is a pivot point, and that helps you to feel the resistance of the cut. Here, on impulse, I've turned the gouge right round 180 degrees so the flute's facing me, and I'm using the scraping action of the bottom wing of the tool, trying to even out any slight undulations caused by the push cut that I had previously. The one problem with this scraping cut is it causes more friction and more forces, and therefore has a tendency to slow the lathe down. Here you'll notice a change in tone of the cutting action, and we're getting some vibration created here due to the thinness of the wall, and this can only get worse as the wall thickness reduces. What I should have done, I should have kept as much wood on as long as possible, established the wall thickness before I started removing the rest of the wood in the middle. It looks like I forgot my own recommendations here. Now that I've left a shoulder, it makes it a lot easier. I've determined my wall thickness with that shoulder, and I can use the shoulder to rest the bevel on to prevent any more skidding or possible skidding across the face of the bowl. Here you can see a little bit of a skate That is a result of the approach angle being incorrect. I should have swung the handle away from me a little bit more. Also, I could tell by the feel that it just wasn't quite right, and what I should have done, I should have rotated the flute of the tool slightly towards me anti-clockwise, perhaps a few degrees, just to establish that sweet spot, and then I'd have got a more efficient cut. Now I've approached what I consider the final stage of the removal of the wood. It's a case of now just using a shear scraping action using the bottom wing of the tool and smoothing out any slight undulations left by the bevel cutting method of the push cut. One of the main problems with bolt turning is the transition stage, where you're moving roughly parallel to the bed of the lathe and then going in a smooth transition towards 90 degrees to the bed of the lathe as you do the bottom of the bowl. This is where it's necessary to have a short bevel. If you have a long bevel like the Irish grind or the Ellsworth grind, you'll find this quite difficult to achieve, and this is why you have short bevels for doing bottom of bowls. If you've noticed, I can't use my body to swing the tool round. I'm having to use my arms to do that. That's because the bed of the lathe is getting in the way. On some lathes you can rotate the headstock so that you get a better access to the bowl turning procedure, and you can use your body a bit more. But needs must, and the human body has a way of compensating. Here I changed my mind. The wall thickness looked a little bit thick, from appearance's sake, so I've used my experience and thought that I can take some more wood off it and make the wall thickness a bit thinner. Notice here how I keep going back to where I started the cut, or there's a little ridge that I can feel with the tool, and I go back to pick up that ridge and carry on turning. It's all a matter of feel, like I keep saying. Wood turning is all about feel and feeling the smoothness of the tool as it transfers down the wood. The vibration noise has now increased, so the wood's indicating to me that it's getting to its minimum wall thickness now. So I think I'll just clean up any undulations on the inside of the bowl and then start the finishing procedure. The tool needs a little bit of sharpening, so I'll go back to the grinder and put a new edge on it before I start the finishing shear scraping cuts. Here I'm just truing up the outer surfaces of both the bowl and the false base plate. It doesn't help when you've got slight vibrations due to eccentricity, so it's better to make everything run true and it doesn't come back to bite you later on. Here I've reverted to a spindle gouge just to clean up the junction between the bowl and the false base plate. I normally aim to get a decent finish from the tool so that I can start using 120 grit. It's a nice yardstick to go off if you're having to use 100 or 80 grit after you've used the turning tools. It's just a little incentive for you to improve your skill level so that you don't have to use too coarse a grit of abrasives. I don't know if you've noticed, but there's a stubborn little ring just below the top edge of the bowl. It proved a little bit persistent, but eventually I got it out. I reverted back to 120 grit when I saw that the finer grits were not taking it out. Here I'm using a multi-tool. You can use a power drill with a disc, a foam-backed sanding disc in it, but I get on okay with my little multi-tool, Ryobi multi-tool, and just slap a bit of abrasives, Velcro back abrasives on, and I can change the grit size as needed. I'm going to apply an abrasive paste, Yorkshire grit, later on, so I usually aim for around about 180 to 240 grit before I start introducing the paste. To apply this paste, just spread it on a reasonably consistent amount around the whole surface, and then keep using a tissue to wear down the abrasive and the pumice until it's so fine that it leaves a very good finish, and it nearly stops staining the white tissue. After using the standard grit, Yorkshire grit, I've reverted to the white, which is the finest of all the Yorkshire grits. I think it's equivalent to about 700 or 800 grit of abrasives. I'm going to apply 1 coat of sanding sealer and 2 coats of melamine on the external surfaces of the bowl. I'm leaving the internal surface of the bowl because we need to find something that's non-toxic and has no allergies. For instance, walnut oil is great for doing internal, it's food safe and everything else, but it does create nut allergies. So there are various products on the market that don't have this, and I'll put them on the screen. Because of the tiny motor, I noticed I used a wider parting off tool thinking I could do it in one cut. But it did slow the lathe down somewhat, so I reverted to a 1/16 wide parting tool and just made the cut about twice the width, and going down at different passes in order to create a width of about 1/8 of an inch to remove the bowl from the false base plate. While I was doing the removal, I noticed I could feel some soft spot in the plywood as I was removing it, and I got a little bit apprehensive about continuing to take it nearer to the centre with the parting tool, so I stopped using the tool earlier than I would have liked, just to be on the safe side, because the one thing about plywood is sometimes the layers of ply are not glued together properly, so I was being cautious and using a saw to remove the rest of it. I've now removed the faceplate from the false plywood bottom, and I'm going to reuse that faceplate to create a jam chuck using another piece of ply. This is why I never throw anything away, especially if it's round, because I have to make it round to put it on the lathe. So I keep a lot of round pieces of wood, whether it's plywood or softwood or pine or anything like that, which comes in useful for this sort of operation. I revert to the sharp point dividers to assess the diameter of the external rim of the bowl, to reproduce that in the form of a recess into the plywood mounted on the faceplate. When using the dividers, it's essential that you line up the point to the exact centre of the disc. If you don't do, it gives a false reading, it gives a false dimension. So make sure that it's on the centre line, and for goodness sake, don't let the right point hit the upward rotating side of the disc. It happened to me once and I took a bit of a lump out of a finger. So be careful with this, but it's so fast to use and so convenient. Again, I'm using the very thin parting tool for this. I don't want to stop the lathe or slow it down, so it's better to have a small cut and just spread the cut to the width that you want. You're probably wondering why I don't use a wider parting tool, for the simple reason that the wider the tool, the wider the cut. The wider the cut, the more forces that slow the lathe down. It's different when you're using a gouge, because you're only cutting on a very, very tiny part of the cutting edge, and you're not actually scraping, you're slicing the wood off. So more energy is created when you use a parting tool or any flat surface being pushed into the wood. I'm going back to my bowl gouge now to clean up the rest of the wood that's in the centre, and I'll keep readjusting till I've got the depth I need. It doesn't have to be flat all the way down, just flat against the external part of the bowl. The recess has to have a nice sharp corner where the edge of the bowl can fit into. I've made it so it's just a nice fit to drive the bowl, but I will support it with the tailstock and a scrap piece of wood. I'm taking this very slowly because it's not a massive firm grip, so I've got to be careful that I don't dislodge the bowl and make it run out of true. Notice I'm just touching the bottom. You can even see the remnants of the PVA glue just touching the rim. After using the parting tool, just remove some of the wood. See, I didn't even have to go right through to the centre. The remnants of the plywood base were just pulled off. Now I'll use a bowl gouge to smooth out the base, but I must remember to press against the bowl at right angles so that and try not to cause a radial load on the bowl, which could dislodge it from the jam chuck. I had second thoughts. I've learnt over time never to assume anything. Never assume that the jam chuck is holding the bowl strongly, so I've still supported it, albeit with a smaller diameter support scrap wood. Here I'm checking to see if I've got a slightly convex surface that goes towards the middle of the bowl, so it'll stand on a table without wobbling. I'm just checking to see that the jam chuck's holding the bowl securely, and now I'm going to just take the knob off the middle of the bowl with the bowl gouge, pressing at 90 degree at parallel to the lathe bed and pressing into the bowl very slightly so that I'm not creating any actual loads that may dislodge it from the jam chuck.
How do they look to get at the group? And it's a tough group, I understand. Getting to the major tournaments a couple of years ago, under 21 level, that type of thing, and the results have not been too bad accordingly.
As usual, 120 to 240 grit, then the two grades of Yorkshire grit abrasive paste, followed by a coat of sanding sealer and 2 coats of melamine. This is where most of the wear will happen on the bowl, so I put an extra layer of melamine lacquer on the bottom of the bowl. You've always to be careful when you do the finishing process, from the abrasives right down to the finishes of lacquer and polish and waxes, etc. Take your time. You can get over enthusiastic about finishing the item and then squander all the skill you've used with inappropriate finishing techniques. So take your time, think about what you're doing, and the results are very rewarding, because once you put a coat of varnish on or lacquer, etc., it brings out the colours of the wood and is just reward for all the effort you've put in. All that's left to do now is be careful, because it always seems to be the last step that goes wrong. You knock the ball off the thing and it goes flying across the workshop floor. So even here, don't take anything for granted. It's happened to me a few times, I can assure you. Just take your time, take it off, use a rubber mallet and some tissue to just dislodge it from the jam chuck.